going to talk about using computer outputs. So yes, you can get a regression line from your calculator. However, what you'll see oftentimes is the question will already give it to you. Okay, so in this example, we have 3 different types of statistical software packages. We have JMP, which is here, JMP is JMP. We have Minitab, and we have DataDesk. Okay, so we have 3 different outputs here. And basically, what you might be asked to do is look at an output and find the information that you need. Okay, so I did put the data points over here. However, in most cases, you don't even have those data points in front of you, and you would just get some sort of output. So it's a good habit to get into of being able to look at different types of data packages and figure out the information that you need. Okay, things that you might be looking for, you might be looking for the mean. We might be looking for R squared. We might be looking for the least squares regression line, and R as well. Let's try to find R. The first question that I want to ask is this one right here. We need to figure out the explanatory variable and why that is the explanatory variable. Okay, so take a second, pause the video. I want you to just take a look through these 3 outputs and just kind of familiarize yourself. What do you see that's the same? What are some things you've maybe never heard of? Familiarize yourself here, and then we're going to, excuse the bell, we're going to talk about this here in just a second. Okay, so let's look at this first one. The explanatory variable will always be listed its actual name. So you'll notice that nowhere here in this JMP output do I see New York. Nowhere here do I see that. That tells me that Bismarck is my explanatory variable. Okay, always shown. So this would be your X or your explanatory variable. Okay, there's lots of things here. We won't use any of this. We won't use the t ratio. We won't use the probability. You should see up here R squared. Okay, so this is R squared. It is really unlikely that you are given R explicitly. But you know what? It's not that hard to find R when you're given R squared. You're going to take your calculator and you're going to take the square root of whatever you have for R squared. So 0.990044. So my R value in this case would be 0.9950. Okay, so it is unlikely that you're given R. It's possible, but it's unlikely that it is given to you explicitly. However, you will be able to find R squared. Okay, should be given to you. The mean of the response variable is here. So that would be the Y bar. We're going to talk about the least squares regression line here in just a second. Let's find maybe the mean and R squared in the Minitab output. Okay. Again, you see Bismarck. You'll notice that Minitab actually gives us the least squares regression line. Now we would have to put a hat over New York. It's estimated New York temperature, so you'd want to keep that in mind. We do have an R squared value. Okay, we don't want to use the adjusted R squared. We're just going to use the regular R squared. It does not give us R. It does give us that there is an unusual observation here. Okay, and it's basically saying it has a large residual. Okay, so if we remember what residual is, its residual is maybe the largest or abnormally large. So it does give us unusual observations. Minitab is kind of helpful in that way. Let's look at DataDesk down here. It does tell us here dependent variable is New York. We do see Bismarck right here as well. We're not going to use the adjusted R squared. We're going to use regular R squared. Here it gives us S. That's the standard deviation of the residuals. All right, let's talk about how we would actually find the equation. So let's look at Minitab, since Minitab actually gives us the equation. You may notice some similarities. We have our y-intercept, and here I see the same number. We have our slope, and here I see the same number. So when you're looking at the Minitab output, the slope is, you're looking for where it says coefficient, or up here it would say estimate. And the one that is next to the x value is the slope. The constant is your y-intercept. Okay, here it says actually intercept as opposed to constant. It says estimate for Bismarck. There's your slope. You can see the wording is just a little bit different. So it's going to be good practice for us to pick out which information we actually can use. Okay, down here on data desk, it has constant and Bismarck. It has the coefficients here. This would be your intercept, and that would be your slope. Okay, so let's look at example 8. We are given a regression analysis from data desk. We are talking about alarm barks in prairie dog towns. They emit alarm barks when there's intruders nearby. Oh no. And it tells us this is the distance that the intruder is away and the frequency of the bark. Okay, so you can start to, look at the line there. Here's the information that we're given. So let's look, and you actually have space. If you're typing it in, you have space on the next page because we have I parts that we need to answer for this question. Okay, so what I want you to do is, based on what you know, you can find the regression line. I gave you a residual plot as well. Based on what you know, I want you to try parts A through I, and then I will go through each of these more in depth here in just a second.